Right, cracking on with question 5 then. This is a trig identity question, and our key trig identities are that the tan of x is equal to sine x over cos x, and that sine squared x plus cos squared x are equal to 1. So that's what we've got to work with. That implies that cos squared x is equal to 1 minus sine squared x. Okay, so the expression we have, tan x square root 1 minus sine squared x, I'm going to put a little there for, is equal to sine x over cos x multiplied by the square root of cos squared x, which is equal to sine x over cos x times cos x, which is equal to sine x as required. Now, we don't need to worry too much about the acute angle bit. This is only true for acute angles. There are values of x that would give us a negative value for sine x, but also a negative value for cos x, which would make tan positive, and the square root of 1 minus sine squared would also be positive, but sine x would be negative. So I think that's only true for acute angles. Maybe I'm talking complete couplers, who knows? Somebody that's good at maths can correct me if that's not true. So part 2, solve the equation that we're given here for values of y between 0 and 360 degrees. So for sine squared y is equal to sine y. So straight away a solution to that is that sine y is equal to 0. Is one possibility, and that would give me y equal to, well, possibilities for y if sine y is equal to 0 are 0 degrees, 180 degrees, and 360 degrees. All of those will give me sine y equals 0. Then if sine y is not equal to 0, I can divide both sides of this equation by sine y if it isn't equal to 0, and I can say then that 4 sine y is equal to 1, sine y equals 1 over 4, and that gives me solutions that I'm going to ask a calculator for, and make sure my calculator is in degrees, because the range in the question is in degrees. So 0.25. So the calculator answer here is 14.5 degrees. 14.5 degrees, but bear in mind, if I just sketch the range, it's from 0 to 360, so that is sine y against y. Sine y equals 1 over 4 happens there, and it happens there. So at 14.5 degrees and at 180, minus 14.5. Which is 165.5 degrees. So those are my answers then. 5 possible values that satisfy that equation, and I believe that's job done.